They say the ocean breathes storms, but sometimes that breath turns into a roar, one so powerful it drowns cities, tears apart coastlines, and leaves scars visible from space. We call them superstorms. But what does that word really mean? A superstorm isn't just a category on a weather chart. It's a scale of power that stretches from ordinary swirling clouds to planet-shaking monsters. So, let's start at the beginning, from the fragile seed of a storm all the way to those that defy our imagination. Level 0. Every storm has a birthplace. For hurricanes, typhoons, and cyclones, that birthplace is warm ocean water. At the equator, the sun heats the sea, pushing surface temperatures above 26.5 degrees Celsius, 80 degrees Fahrenheit. This heat evaporates water, filling the atmosphere with fuel in the form of moisture. When that hot, moist air rises, it cools and condenses into clouds. This releases latent heat, the hidden energy stored inside water vapor. That heat warms the surrounding air, making it rise even faster, creating a feedback loop. But rising hot air alone isn't enough. You need something else: organization. That's where the Coriolis effect comes in, the twisting force created by Earth's rotation. It bends winds into a spin, turning scattered thunderstorms into a swirling vortex. At this stage, it's not a hurricane yet. Meteorologists call it a tropical depression. Wind speeds are below 39 miles per hour, 63 kilometers per hour. It's fragile, easy to tear apart. Wind shear, those crosswinds that cut storms sideways, can shred it. Cooler waters can starve it. Dust blown off deserts like the Sahara can choke it. And most of them do die young. Each year, about 80 to 100 tropical depressions form worldwide, and only about half ever grow stronger. The rest dissipate quietly over open waters. But sometimes, the conditions line up just right. Warm water, low shear, enough spin. And the storm feeds, it grows, it gets a name. Level 1. When winds cross 39 miles per hour, 63 kilometers per hour, a tropical depression graduates into a tropical storm. That's the moment it earns its name. Names matter more than you'd think. Before the 1950s, storms were described vaguely. That hurricane near Florida. Confusion was common, but once meteorological agencies began assigning official names, communication improved dramatically. Now, when a storm like Katrina or Sandy appears in headlines, there's no mistaking it. At this level, the storm's damage is usually limited. Winds can rip tree branches, topple power lines, and scatter poorly secured boats. Heavy rainfall is the real threat. Flash flooding that sweeps through low-lying areas. But don't underestimate a level 1. Even without hurricane strength, these storms can devastate communities. Tropical Storm Allison, 2001, for example, never became a hurricane. Yet it dumped over 30 inches, 76 centimeters, of rain on Houston, Texas, causing $9 billion in damage and killing 41 people. The lesson? Don't get distracted by wind speed alone. Water, rainfall, and flooding kills more people in tropical storms than winds ever do. And for coastal communities, once a storm gets a name, it becomes more than a weather system. It's a psychological shift. Suddenly, it's a threat to prepare for. Shelves empty, streets fill with sandbags, and people begin to watch the sky with unease. But for the storm itself, this is just adolescence. Because the true transformation happens when winds cross 74 miles per hour, 119 kilometers per hour. That's when we stop calling it a storm and start calling it a hurricane. Level 2. The birth of a hurricane feels almost ceremonial. At 74 miles per hour, the storm gets promoted into the official hurricane club. This is Category 1 on the Saffir-Simpson scale, a 5-step ladder used to measure hurricane intensity. On paper, it's the weakest category. In reality, it's already terrifying. At this level, storm surge, the rise in sea level caused by winds pushing water toward the shore, can climb 4 to 5 feet, 1.2 to 1.5 meters. That may not sound catastrophic, but imagine it. Water swallowing coastal roads, flooding homes, eroding beaches, and turning every wave into a hammer against seawalls. Winds rip shingles off roofs, break windows, and knock out power. Entire regions can go dark for days or weeks. Crops get flattened, economies pause. Take Hurricane Florence in 2018. By the time it hit North Carolina, it had weakened to a Category 1. Just a Category 1, some headlines said. But Florence stalled over the coast, dumping relentless rain. Some areas saw 30 to 35 inches, 76 to 89 centimeters, of rainfall. Rivers overflowed, towns flooded, and livestock farms were drowned. The total damage? Over $24 billion. The truth is, minor is misleading. Category 1, hurricanes can kill. And if you've ever stood in winds over 70 miles per hour, you know how impossible it feels to even walk, let alone stand against it. And hurricanes don't stop here. They grow, they feed. And when winds pass 111 miles per hour, 178 kilometers per hour, they unlock the next phase, where major is no exaggeration. Level 3. Crossing into Category 3 is like crossing a line. At 111 miles per hour, 178 kilometers per hour, hurricanes earn the label major. And it's not just meteorological, it's practical. Disasters at this level reshape lives. Roofs don't just lose shingles, they get peeled off entirely. Buildings not built to code collapse. Coastal towns become unrecognizable. Storm surge can rise 9 to 12 feet, 2.7 to 3.6 meters, enough to bury the first floors of houses. And power, gone, not for days, but weeks, sometimes months. After Hurricane Maria in 2017, Puerto Rico's grid was so damaged that parts of the island went without power for nearly a year. The storm caused nearly $91 billion in damages and thousands of deaths, many due to the prolonged humanitarian crisis afterward. Perhaps the most infamous example is Hurricane Katrina in 2005. Though it struck New Orleans as a Category 3, the storm surge breached levees, drowning much of the city. Over 1,800 people died. The economic toll, $125 billion. Katrina became not just a storm, but a generational wound, a reminder of how fragile human infrastructure is against water and wind. At this level, storms stop being local events. They become national emergencies. Governments mobilize militaries for rescue, supply chains break, insurance systems strain, entire communities are displaced. Every single one of these disasters, Katrina, Maria, Florence, began as a tiny swirl of clouds over warm ocean water. That's the story of storms. They scale, they escalate, and sometimes they refuse to stop. Level 4. This is the top of the official scale. Category 5, winds above 157 miles per hour, 252 kilometers per hour. Enough force to turn palm trees into spears. Concrete buildings don't just lose shingles, they crumble. Cars aren't parked, they're hurled. Entire neighborhoods vanish. Hurricane Dorian, 2019, the Bahamas. It struck with 185 miles per hour winds, 298 kilometers per hour, and then it stalled. That was the cruel part. The storm moved at walking pace, grinding over the islands for days. Roofs peeled back, streets became rivers. Some towns were erased from maps. The official toll, 74 dead, but hundreds were never found. Then there was Hurricane Patricia, 2015, in the Pacific. At peak intensity, some agencies estimated 1 minute sustained winds near 215 miles per hour, approximately 345 kilometers per hour, the strongest reliably recorded in the Western Hemisphere. Measurement methods and agency estimates vary. If it had hit a major city, the devastation would have been biblical. Category 5 isn't just a number, it's the threshold where storms stop feeling natural, where they become monsters. And scientists now warn, thanks to warming oceans, we may not have seen the worst yet. Level 5. Officially, this doesn't exist, but nature doesn't care about scales. Meteorologists have debated for years. Should we add a Category 6? It would begin around 190 plus miles per hour, 305 plus kilometers per hour, sustained winds. We've already seen storms flirting with that. Typhoon Haiyan, 2013, struck the Philippines with extremely high estimated winds. A storm surge 20 feet high, cities drowned in minutes, over 6,300 dead, millions displaced. At Cat 6, entire coastlines vanish under water walls. Skyscrapers sway like reeds. Critical infrastructure, power grids, hospitals, ports is annihilated. Climate change is making this less what if and more when. Some climate models suggest a warmer planet could breed storms so powerful they'd make Category 5 look tame. So maybe the real question isn't, should we add Category 6? It's, how soon will we need it? Level 6. Now we step off Earth. Picture Jupiter's Great Red Spot. It's a storm bigger than Earth. We've already seen storms flirting with that. Typhoon Haiyan, 2013, struck the Philippines with extremely high estimated winds, and it has been raging for centuries. That's what happens in a world with thicker air, deeper oceans, and no land to break the fury. Earth can't hold storms like that. Our atmosphere is too thin. Land disrupts circulation. Friction bleeds energy. But under the right conditions, scientists have theorized the Hypercane, a storm born if ocean waters ever reached 50 degrees Celsius, 122 degrees Fahrenheit, something that could happen after an asteroid impact or a supervolcano eruption superheated the seas. The Hypercane is a theoretical construct. If oceans were briefly heated to approximately 50 degrees Celsius, 122 degrees Fahrenheit, e.g., after a massive asteroid or supereruption, models suggest a storm could form with far greater intensity than any modern hurricane. Storm towers punching into the stratosphere, moisture injected so high it could alter global climate for years. Mercifully, Earth's oceans today are too cool for that. But physics doesn't forbid it, and nature has never promised us limits. Level 7. Not every apocalypse comes from heat. Some are born from cold. Imagine this. Ice sheets melt, pouring fresh water into the North Atlantic. Ocean currents, the engines that drive Earth's climate, slow, then stall. The result? Chaos. This isn't fantasy. Around 12,800 years ago, Earth plunged into a period called the Younger Dryas. A sudden return to near Ice Age conditions, likely triggered by massive glacial meltwater disrupting circulation. Now picture storms in that world. Super blizzards swallowing cities, hurricanes slamming into frozen coastlines, mega thunderstorms roaring inland, fueled by violent clashes of hot and cold air. These storms wouldn't just batter coasts, they'd strike deep inland, blizzards dropping meters of snow overnight, tornado outbreaks on scales never recorded, hailstorms flattening farmland across whole states. Could this happen again? Some scientists warn that today's rapid warming is already slowing the Atlantic circulation. Not collapse yet, but the gears are grinding. And if they ever seize, the storms that follow won't just test our buildings, they'll test our survival. Level 8. Now, scale up again. Imagine a storm so vast, satellites can't capture it in one frame. A weather system that covers an entire hemisphere. On Earth, this is rare, but not impossible. The closest example? The 1972 Black Sunday super outbreak of tornadoes in the US. Combined with a massive front, it spanned half the continent. But still, that was only a taste. On Saturn, we've seen storms like this. The Great White Spot, a storm that wraps the whole planet. Lightning strikes thousands of times brighter than any on Earth. Winds howling at 1,000 miles per hour, 1,600 kilometers per hour. If conditions aligned on Earth, say, with runaway warming, extreme humidity, and altered jet streams, some theorists believe a single megastorm could fuse across oceans and continents, creating a hemispheric cyclone. Not just one hurricane, not just one blizzard, but an atmospheric monster that reshapes entire seasons. Planes couldn't fly, satellites would struggle to see through it. Global trade would grind to a halt. We call them superstorms for a reason, because past a point, they're no longer weather, they're planetary events. Level 9. Here's the twist. The scariest storms might not come from extremes, they might come from change. Earth's climate is a balance, a fragile one. Heat moves from equator to poles, water evaporates, condenses, falls, repeats. But shift that balance and storms morph into new beasts. Already, we're seeing hints. Hypercanes, Mediterranean hurricanes that never used to exist, now spinning into Italy and Greece. Bomb cyclones, storms that drop 24 millibars in 24 hours, exploding in intensity along US coasts. Rain bombs, single storms unloading feet of water in hours, overwhelming cities designed for inches. These aren't hypothetical. They're here. They're happening. Level 9 is not one single storm. It's the new normal when the rules themselves shift. When once in a century becomes every few years. When Category 5s aren't outliers, but regular guests. When the map of risk redraws itself before our eyes. Storms that once defined history, Galveston, Katrina, Haiyan, become benchmarks, not warnings. And the truth? We may already be living in Level 9. Level 10. Now, push it to the edge of imagination. The Hypercane, a storm theorized by scientist Kerry Emanuel in the 1990s. Born if oceans heat to 50 degrees Celsius, 122 degrees Fahrenheit. How? A supervolcano, an asteroid strike, anything that turns seas into boiling cauldrons. What happens then? Winds over 500 miles per hour, 800 kilometers per hour. A storm tower punching through the stratosphere. Enough heat and moisture carried aloft to disrupt global climate. One hypercane wouldn't just devastate a coastline, it could wrap the equator, inject water vapor high enough to shred the ozone layer, leave the planet exposed to radiation from space. Civilizations wouldn't just struggle to recover, they might not recover at all. And yet, the laws of physics say it's possible. Not likely, but possible. Level 10 is the nightmare ceiling. The storm is so vast, so violent, it doesn't just destroy cities, it rewrites planets. We began with breezes that sting your eyes. We ended with storms that could tear the atmosphere apart. So, what happens when a storm grows beyond control? It becomes more than the weather. It becomes a force of history. Every storm tells us something about physics, about climate, about ourselves. Because in the end, storms are mirrors. They show us the fragility of our homes, our cities, our civilizations. No matter how advanced we become, we still live at the mercy of wind, water, and sky. The question isn't if the next superstorm will come, it's when, and when it does, will we be ready?